Welcome to A+. For those of you who are just getting started in tech, welcome to the first steps of making this all happen. For some of you, you're already in a tech position, maybe you've been there for 1 or 2 years, and you're ready to take the next steps to make it official, get in the industry, get your certifications, and get more money. So the book that we're going to be using during this course is your exam cram for A+. Now we are studying for 2 different exams here, the 22901 and 22902. And you do have to pass both of those to be A+ certified. So I want you guys to remember that in your book, in the back of your book, there's an awesome resource. So if you flip all the way to the back cover and open it, you'll see that there's a CD here, and this CD has practice tests on it. There are vocabulary, quiz exams. There's just practice multiple choice exams, which are all amazing resources, and that's why we use this book. So put the CD in. If you don't have an optical disc drive in your computer, meaning you can't put CDs in your computer, you can go online and there's instructions to download it, so you'll have full access to the software. All right, so let's get started with what is the 901 and 902. What do you need to do for the tests, and what does all this good stuff look like? So let me share my screen and we'll get into it. All right, so the goal here is to make it through our 900 series exams. Now there are 2 exams like I mentioned before, and there's the 901, which we always start with. Oops. All right. 902 is second. So they launched these exams on December 15th of 2015. But the parts that matter to you the most is that there's up to 90 questions, and most students do get between 85 and 90. There are both performance-based, or what I call SIMs, and multiple choice questions. You'll have 90 minutes to take the test. You'll need to score at least 675 points out of 900 on the 901. And no less than 700 points out of 900 on the 902. Anything at that point or above means that you have passed the exam. And yes, 675 out of 675 is a pass. And no one will ever ask you your score except for us, because we have to keep track of those. You can take this test anywhere in the world. It's also recognized anywhere in the world. So if you end up with an IT job somewhere in Europe or Africa or Australia, this certs will go with you, and they'll understand what they are, and they'll be weighed just as heavily. There are multiple languages that you can take the test in, and usually every 3 years, they'll upgrade the series of the test. So we went from the 800 series to the 900 series, and then we'll come out of the 900 series into what should be the 1000 series. So taking a look at some of those differences, especially for you who used to study the 800 series and maybe didn't take the test or are looking to upgrade that knowledge, we're going to be focusing a little bit more on troubleshooting than the 800 series did. They've definitely increased both the mobile and cybersecurity sections of this test. And you'll see that as we go through the content, that we're going to focus a lot on both of those. And there's a greater diversity, meaning they've pulled in more information from other operating systems than Windows, as well as looking at more than just the Android and iPhone options. Don't forget BlackBerry and Windows phones still exist. We've definitely got some options in the cloud that we need to take a look at. And virtualization is something that's being integrated everywhere, even if you don't necessarily recognize it. Now, the 901 exam objectives focus on 4 primary areas. And the first is hardware. This is where we're going to be looking at how to put a physical computer together, how to break it down, and how to troubleshoot anything that might go wrong with it. Networking is 21% of it, and that's how to get something online or get a device to talk to another device. Doesn't necessarily have to be internet-based, but we've got to get them communicating together. Mobile devices, of course, is anything that you can move with you. You're not having to unplug and go through a big deal to take it from point A to point B. So that includes your phones and tablets, but it also includes laptops, because those are mobile. And the last section of it is troubleshooting all 3 of the previous sections. So when something goes wrong with your hardware, when something goes wrong with your network, or something goes wrong with your mobile devices, we need to be able to identify the issue and go through the steps to making sure we can resolve the issue. Now that is the first exam and everything that will be covered on it. The second exam is the 902. And this has 5 primary domains that we're going to be looking at. And the first is the Windows operating system. It is still the world leader for ROS option, and therefore is just under 30% of our exam. Other operating systems and technologies will include Linux, Unix, and Apple formats, and we need to take a look at those because they're growing. The third section or domain that we'll be focusing on is security, and that's a huge deal because, as you have heard, and I'm sure even talked about, getting hacked or hacking someone is a real issue in today's world, not just in the United States, but anywhere in the world. So we're going to take a look at how to secure your mobile devices, your operating system, both on the physical and virtual side. The fourth domain is software troubleshooting. So when Windows tells you it has an issue, or you have an IP address conflict, or your printer doesn't work, which is probably the most common, we're going to take a look at how do you fix those issues. And the last and the smallest of our operating domains here that will be tested on is our operational procedures. And that is, what is the appropriate way to go through a troubleshooting process? How do you talk to your customers? What are the steps that you should be going through prior to touching a computer? Making sure that you have the right forms and documentation filled out. So those are definitely important things. Maybe not the most exciting part of it, but usually the most important, because if we have a problem happening over and over and over again, we want to make sure we have that documented so we know how to go through the process and stop it. And hopefully we can actually find the source of the problem and alleviate it from happening in the future. So with that being done, we can actually take a look at our first PowerPoint in regards to getting started with our training. So let me get that up on your screen. And we're going to jump right in. So the first thing we'll be looking at are PC components. And we're looking at all the different things that make up a PC that's normally in your home or office. We're going to take a look at different types of storage devices, different types of mobile devices, and different types of connection interfaces. Now, I'm not going to be reading every slide to you, so don't get used to that. Most of these are going to be image-based, and we're just going to be talking about them. Now, this does align with what's in your book, but you'll see that some of the things that we talk about will go a little bit more in depth, especially if I know that they'll be on your test or exam. And some of the things I will be telling you to look in your book for those more than necessary details per se, because not all of us are going to be memorizing the nitty-gritty details to RAM and the megahertz and gigahertz of all the things that we'll talk about in class, because we have Google to look up those things when they're needed. But you do have to have a basic familiarization with what they mean. So the first thing we're looking at here is just what makes up a computer and how do we pinpoint what device is what. So when we talk about a peripheral device, that's something that we can plug into a computer to interface with it or interact with it. Our system unit itself is what most people call the computer or the tower per se. That's where all the parts are held inside, as far as the motherboard, the CPU, and all that good stuff on the hardware side that we're going to be taking a look at. Display devices, anything you plug in to receive a display from the system unit. Now, this can be a classic monitor like you see. It can be a projector, a television. There's lots of options now. You have input devices, which means anything you plug in that you'll be putting information into your system. So we're inputting information with our keyboard. We're inputting information with our mouse. And we have other input devices that we'll take a look at as well. And of course, we have one more peripheral device. These are optional devices that increase the user experience or improve the user experience while you're on your computer. So being able to listen to music or listen to your YouTube videos as you're watching them, that might take place on internal speakers, or you may have upgraded that and have peripheral devices or external speakers that you've plugged in. So the motherboard is the brains, specifically the CPU is the brains of the computer. And this is where we plug everything in on the motherboard to interact. So everything, whether it's internal or external, that we plug in physically to a computer, to the motherboard. So you'll see lots of different slots and chips and capacitors and different things going on here. And we're going to talk about those in depth when we go across each section of the motherboard. For this section, this is just an overview, so don't get caught up on what is every tiny little thing quite yet, but we will get into that detail. So like I said, the CPU is the brain. You have to know that this is the thing that processes all the data that you have coming in. CPU stands for Circuit Process Unit. So this is where you're going to have all of your data going through and making decisions. Next is our memory, or your RAM is what we are most familiar with calling it. And this is going to be what is in those slots that you saw on your motherboard. And for, say, about 90% of the time, the rule is that these are always installed in pairs. So your RAM, your random access memory, is going to be installed always in pairs. Don't forget that. And we'll talk about different types of RAM when we come to that chapter. Now, all of our data that we're putting into the computer needs to travel from point A to point B. And point B in this section is going to be your CPU, meaning that all the data and decisions, all your ones and zeros, need to travel to your CPU to get processed, and then a response takes place. And that is going to happen on the system bus. Those are the lanes and the speed limits that are going to be applied to our data as we're transferring it in our computer. So all of us need to store data. We used to be really big and reliable on external hard drives, and some of us still have some pretty cool ones in the terabytes now. I remember when 500 gig external meant that you had the latest, greatest, coolest external, and now you can get that on a USB. So we've got external storage devices that we can plug in. They're really fast. They can hold an immense amount of data. We also have internal drives that you see there in the center. And those are going to be the place where we either have a solid state or disk drive that we're saving our information on locally. That means it's coming with us on our laptop per se, wherever we go, or it's stored in the computer. Not something that we're unplugging and plugging back in very often. And then of course we have some USBs and we have SD cards that we're using now. So we'll take a look in depth at what those capacities are and what type of storage devices. But you can have internal or external storage devices, and these are pretty common nowadays. Now, everything needs power to work correctly, and your power supply unit is an important part of your computer. Now, this is one for a tower computer or a full box computer or system, not necessarily for a laptop. That wouldn't fit in any laptop that's made nowadays. But you have different components to these power supplies, including a fan. Some of them will have a voltage switch because we have different types of power or different amounts of power in different places in the world. Of course, we should have a power switch to turn on and off the power in our computer, and we'll need a socket to actually plug it in. Now, everything in IT creates heat. Our CPUs create heat, our graphics cards especially create a lot of heat, and so we need to cool those off. And we usually do that using one of two types of cooling systems. It'll either be an active cooling system or a passive cooling system. Now, active means it has moving parts, and passive means it does not have moving parts. So when we take a look at something called a heat sink, which you see there in the silver, and it has a whole bunch of little slots on it, and I'll point it out here on my screen. So that's a heat sink, and we'll talk more in depth about those, but that's a passive cooling system, meaning that there are no moving parts. Now, of course, a fan does move, and that's going to make it an active cooling system. And you will see active and passive cooling components used together to alleviate heat from different components of your computer. Now, there are hundreds of types of expansion cards, and you can get them for pretty much anything you'd like your computer to do. So whether we are looking to upgrade our graphics card, make our computer wireless. For those of you working on some older or legacy systems, you'll understand that there were wireless cards that we used to upgrade. They may have actually at one point been external, just depending on how old the systems you've been working on. We have audio cards, TV tuner cards, capture cards. There's all different types of expansions that you can integrate into your motherboard. And right there at the bottom where the connector is actually where it connects to your motherboard so that that data can be processed. Now, if you've ran out of places for your cards, you can actually use what's called a riser card. And that's going to allow you to use more than one card on your motherboard, meaning that you can plug in the cards, let's say perpendicular or at a 180-degree angle, so that they're not necessarily plugged directly into the motherboard, but this is kind of like an expansion hub. For those of you who used to run out of USB ports on your computer, you probably got a USB port hub where you can connect one of them into your computer as far as a USB, but then that device would allow you to plug multiple USBs into it. So this is an expansion slot for your motherboard. So you can actually put in more than one expansion card and have it run through one slot on your motherboard. Firmware, there's a million ways to describe it, but I think the easiest way for us that aren't necessarily familiar with it is that it is a very, very tiny piece of software. It's actually a script per se. And these are the instructions that tell every piece of hardware how it can or cannot interact with whatever it's plugged into. So if I have firmware for my keyboard, it is going to tell it that it is a keyboard and what the keys can do and what they're supposed to do. It tells my mouse that it's a mouse. It tells each piece of hardware what is going on. And at any point the manufacturer needs to make a major or critical upgrade, you'll see that they'll actually send out a firmware update. Now, one of the most important things on your motherboard and that you'll interact with in the troubleshooting phase is called your BIOS. It stands for Basic Input Output System. And there is a specific chip on your motherboard that is your BIOS chip, and that is going to hold the information from your BIOS menu even when you turn your computer off. So that's its storage place. Now, in your BIOS is the place where your computer holds the information in regards to where to find your operating system, how much RAM it had the last time, and how much RAM it should have at the boot up stage, and the system clock information, among other things. So every single time you boot your computer up, the BIOS is actually what starts first in the background and make sure that all things are okay and all systems are a go before you get to your operating system login screen. Now, the newer version of BIOS is the Uefi Screen. It's very similar to your BIOS, but it's upgraded in regards to it looks much prettier, and you can use your mouse in the Uefi interface. You could not use your mouse in the BIOS interface. Now, we talked about to make sure that when your computer boots that it passes all of the different tests, and those tests are called posts, or power on self-tests. So you've already gotten a little vocabulary. I want you guys either taking notes, making flashcards, or reviewing this in a digital flashcard environment. So post and BIOS are definitely probably two new acronyms for you, but make sure that you are familiar and comfortable with what they mean. So power on self-test for post and basic input output system for BIOS. So we can take just a few seconds here, and I want you guys to see if you remember what the different components were labeled for our PC. So at first, of course, that's a printer, but what is it actually called in regards to if we're plugging it in or not? What's the vocabulary word for that? We have the next thing, which is the computer. Of course, I'm not using the words they want you to use, so make sure you know the right things here. Then you'll see the screen, we have a keyboard and mouse, and some speakers. So the right answers, or the correct answers, starting with the printer, is it is a peripheral device. Then we have our system itself. Then we have our monitor. We have input devices for the keyboard and mouse, and another peripheral device for our speakers. So take a moment here and see if you can identify some of the components of just a basic side shot of a computer. I'll give you a second to take a look at those, and we're actually going to talk about each one of those in detail today. All right, starting at the top left on your screen, we have a power supply unit. Then we have our RAM slots, we have drives, and we have our drive connectors down at the bottom. We have different expansion cards on the bottom left, and then we have our fan, which is our CPU fan, at the top left. So that's going clockwise, starting at the top. And we're going to take a look at each one of those components as we go through our studies today. And we're going to start with different hard drive characteristics. So there are different types of hard drives, but what I want you guys to see here is that there's a trend in regards to how to refer to them. Now, this is one type of hard drive and one of the fastest that we connect to. And SATA is actually the type of connection we're using for this drive. And I'll show you a picture of a SATA connector at the end of this slideshow. So if you take a look at the SATA 1.5, it is called that because the transfer speed, or how fast it's transferring data, is at 1.5 gigabits per second. Now notice I did not say gigabytes. Look at the B. In GB, it is a small b, and that stands for bits. Take a look at the SATA 3 gigabit per second. You'll notice again the transfer speed matches. Now at the bottom, you have an eSATA, and that's because it is external. The E stands for external, and that means we're actually plugging an external drive in with our SATA cord. Now there are different types of storage, but solid state is the preferred one of today. And we're talking about anything without moving parts. So these are not our disk drives by any means, but these are the things that we're storing data on. None of the parts move, and they're pretty mobile. So our USB flash drives, we all have had interaction. We probably have 100 of them floating around the house, or have lost a few at one point or another. They come in different capacities, and those capacities are definitely growing. And we're actually on USB version 3 now, and you may, if you have a newer computer or laptop, notice that one or more of your USB inputs on the computer, the ports, are blue. And that means they're able to read information faster than the ones that are in black. The blue are 3.0 and the black are 2.0. Now, solid state drives means that, again, there are no moving parts. The cool thing is they don't need any batteries or outside help. As long as they're plugged in to your drive, they are good to go. And they are incredibly fast in comparison to our disk drives. Now, some non-traditional types of solid state storage include different types of cards, and we'll just quickly go through these. Some of them were made specifically for different types of digital cameras or recording devices. I know that we have some what we call proprietary cards, meaning that they were specifically for a Sony device, specifically for a Kodak device, and then we have some that are non-proprietary or can be used in different places. So we are used to our SD cards. What you're actually probably used to are your micro SD cards. Those are the really tiny ones that go in your phone. And those things can hold more and more and more these days. We started with 8 and 16 gig cards, which was a big deal. We now have 64 and 128 gig cards. But in all reality, they can go up to 2 terabytes now, which is an immense amount of data. Now, those, of course, are not the ones that are in your phone, and they are not cheap, so you're not going to go on Amazon quite yet and get one of those, but I'd give it about a year, maybe a year and a half, and you'll see those come down in price and be on the public market. So we do have hybrid drives, which means they're combining the solid state functionality with hard drive disk capacities and performance. So you're taking the best of both worlds and putting them together, and we call that a hybrid drive. Now, another way to hold information or store information is on an optical disk. These are CDs, DVDs, and Blu-rays. Now, each one of these is going to have a different capacity, and there are quite a few. We have this slide and one more slide to look at, but it's not that hard when you take a look at the overall and understand the acronyms that are at the end of what you're used to of just seeing a CD or DVD. Now, everyone here should be familiar with, at some point in life, we used to burn CDs. That was a big deal. But you can't burn to a CD-ROM. It had to be a CD-RW, which meant rewritable. Either one of those are going to hold about 860 megabytes at the max, but you'll see ranges of 700, 750. So if you ever asked a question, what's the best place to hold about 720 or 750 megabytes, then a CD would be the right answer. Now, if they're looking to burn or put that information onto the CD, it does need to be a CD-RW. Now, same concept with our DVD. A DVD-ROM, which is read-only memory, cannot be modified or configured. You can't, quote-unquote, burn information to it. But it has a capacity of 4.7 gigabytes, which you can see is a lot more than the few hundred megabytes that we could hold on a CD. Now, there are DVD writables, and there are dual layer DVD writables, or recordables, I should say, and those have larger capacities. But all of the single layer DVDs, whether they're rewritable or not, are going to have a 4.7 gig capacity. When you get to the dual layer, you have an 8.5 gig capacity. And of course, we have Blu-rays, and Blu-rays hold an immense amount of information, up to about 128 gigs. Now, the only thing you need to remember are those four numbers as far as, and I'll go back to the other slides, you can see it here. CDs hold a max of about 850, I would say is a good number to remember, megabytes. DVDs hold up to 4.7 gigs, dual layer DVDs 8.5 gigs, and Blu-rays up to 128 gigs. So if I asked you the question, I'm looking to store about 30 gigs of information, what is the best optical storage medium for that? Does it fit on a DVD? Not at all. It's above the capacity for a DVD. So I would have to use a Blu-ray. So we need to make sure that our drives that we're using are capable of reading the types of CDs or DVDs or Blu-rays we put in. Not all CD drives can read DVDs. Not all DVD players can read Blu-ray. And if you have a digital drive that can read more than one, meaning it's a Blu-ray player and a DVD player and a CD player, it's actually what we call a combo drive. And so for those of you who want to stick a Blu-ray in your Xbox 360 and it does not work, that's because it is not compatible. It can read CDs and DVDs, but not Blu-ray. So you have to make sure your drive is compatible with what you're asking it to do. Now, tape drives are something that you probably think are old and nobody uses them anymore, but the fact is we actually still use them every day in big enterprise environments. The US government backs up almost all of its information to a tape drive, and that's because they are safe and they hold all the information, petabytes, exabytes of information. So way beyond our normal gigabytes and terabytes that we're holding in this small office or at home use. They may not look as old as what's on your screen. They've maybe gotten a little fancier, but we still use this every day, even still, and we will for a long time. So like I said, there's different types of cards. This is definitely a special one. An Emmc Drive is all about multimedia, and it's flash memory and making sure that, let's see, the special part of this is that on the same die or in the circuitry is processing and storing the information. So this is not something that you'll see on your test, but a different type of solid state storage that you'll have the option to implement depending on what your job role is and what type of systems you're using. Now, a quick overview on mobile devices. So these are pretty straightforward. You've probably seen and heard all of these words before, other than phablet. Now, you have a laptop, tablet, smartphone, we're good to go. But a phablet is something between a tablet and a smartphone. And the specifics there are it is between 5 and 7 inches. Anything smaller than 5 inches as far as the display is considered a smartphone, and anything larger than 5 inches up to 7 inches is a phablet, and anything above 7 inches is a tablet. So like I said, laptops you're probably pretty familiar with. We're going into the place where most of our displays are touchscreen. So if you're in the market for a new laptop, you will probably end up with a touchscreen display in the near future. And that is or was something that was held for phones and tablets at one point. But of course, we're expanding that technology into the laptop market. Now, tablets are not necessarily something of the past, but I've noticed as our phones get bigger, our tablet sales are definitely decreasing. But just to touch base so you're familiar, all tablets have touchscreens. They have a virtual keyboard on screen, and they are all solid state, meaning that there are no moving parts in regards to their drive or their internal pieces. Now, we have lots of different kinds of phones. iPhone and Android, of course, consume the majority of the market, but BlackBerry and Windows are major players as well. So again, that phablet screen size is there on your screen so you can see. It's a little bit larger than a smartphone, but not quite as big as a tablet. Most of us that have a phablet still consider it a smartphone. So not something you need to integrate into your everyday vocabulary, but something you do want to be familiar with for the test. Now, wearables are expanding by the minute. A lot of us have smartwatches now. Some of our watches are actually a phone in themselves, so they're not dependent on being connected to a phone. They'll have their own phone number. You'll be able to text from them without necessarily connecting to your phone. And you can leave that Bluetooth range, meaning you can leave your actual phone at home and wear it to work or out with you, and you'll have all the capabilities of your normal phone. Now, our headsets, Google Glass, of course, tried, and from what I hear, they're going to try again. But there are different types of wearables out there, but our smartwatches or Fitbits are definitely the most popular. Smart cameras are a thing, and what this means is from your digital camera that you can directly upload to social media or a drive space, meaning that you can store it in the cloud without necessarily having to go home and plug your phone in. You can upload it via a wireless connection and it'll automatically be online. E-readers are still a thing. They're very much like a tablet, but usually the primary difference is that the screen is matte instead of glossed, so it makes it much easier to read text on them. GPS devices have pretty much completely been integrated into our phones for personal use, but these are still in use in enterprise or business environments. So think about all the trucks that you see out on the road, or commercial vehicles, or I'm saying business vehicles, the trucks with the city or state logo on the side. Those usually still have their own GPS system separate from the driver's phone for tracking purposes. So anytime we have a device, a computer or system that we want to plug things into, we need to make sure that we have the ports to do that. And the one port that I want to spend just a moment on and reminding you that exists is this mouse input port right over here. You see the purple and green? There used to be, back in the day, these connections called Ps2 ports, and those do not stand for PlayStation 2 by any means. But Ps2 ports were our mouse and keyboard input, and we actually used to plug it in here. It wasn't USB. Now we've long since moved past that, but you do need to be familiar with the different types of ports throughout at least the recent history in computing, because you may still see some questions on those. Now for your video ports, you might be looking at what the heck is that? That's HDMI on the right, but what is that thing on the left that has all the holes and is a lighter white or creamish color? Well, that's a DVI port, and we'll be talking about different types of ports when we get to the display section for that. So every port needs to have a cable of some sort, unless it's wireless, and we'll be talking about wireless versus wired connections, but it needs to make sure that you can plug it in on both ends, there's no damage to the cable, and that you plug it into the proper ports on each device. Now, everything you plug in is going to transfer information, and information can be transferred one of two ways: either analog, which is in a waveform, or digital, which are ones and zeros or on or off. And every cable has some type of distance as well as speed limitations, meaning you shouldn't be stringing a 10-foot USB cord around expecting the best data performance. USB has actually a 3-foot maximum range on it as far as reliable communication. Now, some of us use USB extenders, or we got the really, really long cord so we can plug it in on one side of the house and use it on the other side of the house, but you're not getting the most power and you're not getting the best data transfer from there. So let's take a look at a few slides about different types of connections, and then we will end this section. So there are two different types of USB, type A, which you're used to, and type B, which is the bigger squarish one that you probably have no idea what that thing plugs into. You probably have one or two of these floating in a drawer that you haven't opened in a while, and the device it belongs to is probably in a different drawer and you have no idea how to connect it. Well, USB-B, or type B, connects larger devices and multimedia devices. So a lot of times we use those for our digital cameras or our printers. If you had a camera printer, which means you connect your digital camera directly to the printer, usually to print pictures off of it, those used USB type B. On the camera side or the smaller device side, it would usually use the mini USB, which is like our micro, but just a little bit thicker. And of course, our micro USB is what we're plugging our phones in with if you have an Android. And if you have an Apple phone, you're using your own little set of proprietary goodness. IEEE 1394. This is one of those things I want you to write down or make a flashcard. IEEE 1394 equals Firewire. It is an Apple proprietary standard or cord, meaning they created it and they own the rights to it. And it's one of the ways where you can transfer information from a device to a system. Of course, our Thunderbolt cords and ports are Apple proprietary as well. And this will transfer display from Apple devices to your system, or from your Apple laptop to a projector. SATA, again, like I said, was a drive connector. So this is a SATA cable, and you'll see that it has a separate power cable, meaning that you do need independent power for your drive. And this is one of the fastest ways we can connect an internal drive to our motherboard for our storage. So this is a storage drive, and this is the connector that we use to connect it to our motherboard and to the drive itself. Different types of connectors for our display. VGA and HDMI are the most common. You've probably seen these. VGA connectors have 15 pins, and that's important to remember because you may have a question about what is a DB15, and that is a 15-pin connector, aka VGA. HDMI connectors actually have 19 pins, but they're very tiny and they're on the inside, so you don't see those. And of course, I had just mentioned that crazy looking connector that you may have not seen before is a DVI connector, a digital video interface. So some of our old school connectors that you need to make sure you're familiar with: RCA cables, which are different, by the way, from RGB cables. So know that there's two different ones there. So RCA, or component cables, are the red, white, and black, or red, white, and yellow, where RGB cables are red, green, and blue. We have coax connectors here. You'll see an example of a fiber or optical connector. In your home, you're probably using that if you have a sound bar setup. We have an RJ45 or Ethernet cable there. RJ11 are phone or telephone cables. And then those old school legacy PS2 mouse and keyboard connectors. We also have different types of adapters. So anytime you need to plug something in and you don't have that port, but you have a different port, you can use an adapter. And this will allow you to still use a connection that you don't necessarily have the port for on your system, so on your laptop or on your computer. There are lots of different wireless devices that we'll talk about and different connection methods. The most common that you use every day is Bluetooth and Wi-Fi. And so we'll take a look at the specifics for those and get that in-depth information for each of those. But I want to make sure that you guys see just an overview here, and that's what this whole PowerPoint was about, of all the things that you're going to be learning about in A+. Now, did we go over a lot? Yes, we did. But we didn't really go in depth to anything quite yet, and I don't think there was a whole bunch of new information, but probably just a lot of information. So don't let it scare you. It'll definitely be an easy course to get through. You'll be reminded of some things that you haven't used in a while, and you'll learn new things about the devices and components and connections that you're already using every day. So let's take a quick break here and make sure that everybody's connected and in the right places, and then we will jump into our next chapter. All right, let's talk a little bit about how to install and configure all this stuff that we can plug into our computers. So we can plug in just about anything we want as long as it has the right connector. And one of the most common things that we start with is an external keyboard, especially if you have a smaller laptop system and you're using it at home like I do. then I have a wireless keyboard and mouse that I plug in, and so that way I'm not necessarily having to use that super tiny truncated keyboard that comes with the laptop. So there are different types of keyboards that we have. Our standard is what's called a Qwerty keyboard, and if you take a look at the top row of letters, you'll see that it actually spells out Qwerty, which is how this got its name. Now there are different orders of letters on keyboards, as far as some of them maybe go A, B, C, D, which would probably ruin and wreck my typing speed and ability to go through and communicate smoothly through our keyboard, and probably yours too. But there are lots of different types of orders that are still being tested out for efficiency. Some of them have actually proven to be more efficient than the Qwerty standard, but it's kind of hard to change something the whole world is used to. Ergonomic keyboards that you see there in the center are ones that have a different shape for them to help us be more comfortable, especially for those that work at a computer 40 or more hours a week. You want to make sure that you have something that is the most comfortable so that you're not causing damage to your wrists or your fingers. So mice or mouses are the same thing. We have different types of mice. We definitely have ergonomic mice. Our classic is in the top left there. We had a trackball mouse. A lot of you may still use those. Touchpads are something on your laptop that we've all used. Track points are probably a reason for frustration in your life at some point, but some computers do actually still have those, even currently being manufactured. Fun peripherals that we have for input devices are gamepads and joysticks. And we may have customized or unique input devices that we use for different types of programs. So if you're a gamer, you definitely have something that's different than just a mouse and keyboard. If you're using specific systems that you need to input information on, you may have a barcode reader or scanner connected to your computer database. A lot of us have scanners or all-in-ones, meaning input and output devices for that, where you have a printer, fax, scanner, copier, all-in-one type device. But these are all things that you can plug into your computer and use. So we have different multimedia devices. Webcams were the most common. Now those are usually built in. We may have separate microphones. Again, those are now usually integrated, but if you want a nicer or upgraded version, then you'll have something that's external. You can plug your digital camera or camcorder in and get data into your computer. But what is up and coming, and you may not have at home, but you probably have in your work environment, are security input devices. Now this may be to access the actual building or to gain access to your computer. We even now have fingerprint scanners on USB drives. So we're really using different types of biometrics and security to lock down our data and only give access to those who are supposed to have access, and of course, lock everyone else out. So these are really cool devices. They're continuing to improve and come on the market and be a little less expensive as time goes by. At some point, everyone will have to scan into their computer with something other than a username and password, and that's coming here pretty quickly. So whenever you're installing an input device, we need to make sure that we have some boxes checked. First and foremost are the drivers, and what you will hear about over and over and over again are the drivers. If something's not working right, the first thing you're going to do from the OS or operating system side is check your drivers. Not only do you have them, but are they updated and the most current? You need to also make sure that it is compatible for the device that you are plugging it into. Meaning, if you have a piece of hardware that only works with Apple computers, then you're probably not going to have a lot of luck plugging it into a Windows PC or Linux operating system or Unix operating system. So you need to make sure that one, you have the drivers, and two, it is compatible. Now, when you are plugging something in, you can always go to the control panel and look at what is going on per se and customize and configure the device that you're plugging in. So when you go into your control panel, you'll see different sections, but the third one down is hardware and sound. And this is the first place you should go to see all the devices and printers that you have, as well as adding a new printer or device to communicate with your computer. Now, if you have a third-party device, which means something special that's not a major normal everyday piece of equipment. You want to have a PS2 controller or now PS4 controller work via USB on your computer, and you bought it from some crazy company that you can't pronounce, from eBay or some other just random shop that you found online. So one of the things that may happen often is when Windows goes through their updates, they may not recognize the drivers that are compatible with this piece of equipment. So you want to make sure that you actually go to that manufacturer website and install the drivers from there. Another thing that you want to check before even buying it is that, again, it's compatible with your hardware. So we talked about input devices, which is how to get information into your computer, but now let's talk about output devices. Now this is where you're going to get information from your computer. So a display device is the most common. You are seeing things, a reaction to or response from whatever information you're putting in. You're needing a response out, and this is where we see it on our display device. When we ask for data to go from digital to paper, we're asking our computer to send it to a printer and give us that data. So again, you're getting output. Speakers are giving you sound, headphones can give you sound, Braille printers are going to give you paper, but in a, for those of you who are unfamiliar, that is how people with visual impairments or that are blind can actually go through and read. So Braille printer will put text into a format that they can touch and feel. And a screen reader is going to give us an audible response. It's going to read the text that's on the screen. So all of those are outputs from our computer itself. One of the coolest, especially for gamers or entertainment, is what we have, or what we call surround sound, which means you have lots of speakers that quote unquote surround. And I put a little bit of emphasis into this because most people forget that surround sound does mean all around or 360. So if you only have a speaker in front of you, even if you have a subwoofer incorporated into your system, those two pieces do not make it surround sound. You've got to have speakers all around you. So all of our devices need a place where we can go manage them, see what's going on, see what version we have, what drivers they have, and the place to do that is called the Device Manager on the Windows side. So you'll see here, this is a Windows 8 screenshot of a Device Manager, and each one of those sections, you'll see a little arrow pointing towards them. And that means that there's a drop-down option. So you can click on that drop-down arrow and see what keyboard or keyboards you have plugged in. This will include the one that is attached to your laptop, as well as any external hardware or peripheral input devices that you have plugged in. So this is a really good place to monitor and troubleshoot what's going on and see what you have and need to update maybe as far as your peripherals and making sure they work. Now, one last section that I want to overview as far as our input and output devices are things that do both. So I talked a little bit about what is called an all-in-one. You may see the acronym AIO, all-in-one. And those are multifunction printers or multifunction devices. This is where you can put in information to your computer as well as get information out of your computer. So specifically for this device, I want you to take a moment and think, what is one way you can put information into your computer through an all-in-one, and what is one way that you can get information out of your computer using an all-in-one? All right, so let's take a look. In regards to putting information in, and usually this is the biggest challenge for people to come up with, we're talking about scanning information into your computer. We're taking it from paper to digital. So that's an input method. Getting information out, of course, is printing something. So if you have a Word document or graphic that you need to get onto paper, you send it from your computer to the printer, you're getting information out. So different ways to get information in and out of an all-in-one device. Now, KVMs are really cool things. It stands for Keyboard Video Mouse or Keyboard Video Monitor, which is what I actually usually refer to it as. And that's because you can plug multiple pieces of equipment into this piece of hardware, multiple keyboards, videos, keyboard, monitors, and mice or different peripherals into a KVM, and you can have them work with multiple systems. So if you have more than one computer, you can plug different peripherals into this and have different sets. On the other side of that, if you have more than one monitor and keyboard and mouse, and you're looking to use them with the same system, you can do that with this as well. So it's a really cool piece of hardware. Probably don't necessarily need one in your home unless you have a full at-home lab or gaming system. But at work, when we have multiple systems going, this is a great piece of equipment, so we're not having to plug in and unplug different peripherals into different systems all day. Touchscreens are pretty common now. You've got one on your phone. If you have a tablet, it's touchscreen. If you have a laptop, there's a chance that it's touchscreen. But the point of this slide is to remind you that it is getting more and more common for things to have touchscreen inputs or displays. And so we actually, at this point, even have full projector systems or whiteboards that are touchscreens as well. Not necessarily a common at-home tool, but something you'll see in business or classrooms pretty often. Smart TVs were really popular for a second. They definitely still exist, so we need to make sure we're familiar with them. App-enabled TVs, which means you actually had apps on your TV integrated with it, where you could connect to your Netflix account, your Facebook account, you could go directly onto YouTube, and you didn't necessarily need a whole computer in its traditional sense plugged into your TV to access those things. Your TV actually had its own operating system, which allowed applications to be uploaded to it, and it could directly connect to those things without having to plug it into an external computer and then just display it on the screen. Those of us who still have cable, we still have a box of some sort to connect to it. So whether it's Comcast or Time Warner or any of the other crazy options out there, you have some type of box where you're able to interact with it, change the channel, change the settings. They control what you do or don't have access to there. So this is a piece of IT equipment. You may not see it as that because it's just your TV box, but there's actually a lot more going on in there as far as access control, meaning what programs you do and don't have access to as far as the channels. It has a wired connection behind it. So we're going to learn about those things when we go into wired communication and different devices. About expansion cards, and there were a lot of different types, and here are just some of the examples. Now, all of us should have a USB card. We should all have a wireless card in our laptops, in our computers, and that allows us to. Some of the ones that are not as common might be TV tuner cards, meaning that we can actually tune into live channels via our computer. We may not have video capture cards. That means that you're actually able to capture video from your screen. For laptops, we do not use riser cards, but in tower or full system boxes, you may have a riser card. But these are, like I said, just some of the examples that you can have for those expansion card types. So the good thing, or the most important thing to consider here, is that they are compatible and you need to configure them. So most of us are used to a plug and play environment. In today's world, if you plug something in and it doesn't work, it's broken, right? That means, oh, I have to go do something special, or I have to go do some type of update, or what is wrong with it. But plug and play, to be completely honest, is one of the most dangerous things to have enabled on your computer, because that means you could plug in a USB device or a new drive and automatically start loading viruses and malware and spyware to your computer. So for anybody who's on the security side, we are usually disabling plug and play in anything and everything we can. For most end users in the home environment, if it doesn't play as soon as it's plugged in, we think it's broken. So just be aware that maybe plug and play is not enabled or compatible with that device, and that doesn't necessarily mean it's broken. If you need to do a manual installation, that means that you need to go get the driver. Sometimes it comes on a CD. Most commonly now, you'll just go to the manufacturer's website and download it, and then you'll install it, and everything will be good to go as far as running that new peripheral. that is the end of chapter 2. I hope it wasn't too bad. I am going to transfer to a 5-minute break for you guys so you can let your mind rest. And then we are going to jump into our chapter 3. For any questions, you have received instructions in regards to how to share those questions. You're in a Google Classroom where you can post any questions that you've had about the chapters, and they will be answered via text there. So don't forget about that part. We are here for you to make sure you get your questions answered. Enjoy your break, and I'll see you again in about 5 minutes. All right, it sounded like we had an issue with somebody being able to hear me. So I just wanted to double check that you can hear me. So don't forget, if there's ever a time that you have a tech issue or you have a question about class, that you go onto the Google Classroom and submit those questions. We have not only myself, but somebody else who's monitoring that probably about 16, 18 hours a day. So I can't say that we're at 24-hour-a-day coverage because we still need to sleep. But if you have a question or a concern about a certain part of a video that we've gone over, or a slide that just didn't make sense, we have all kinds of resources for you. So we have frequently asked questions, blogs, and articles that we can refer you to. If we need to let you know what page in the book you should be looking at, all of that is there. So don't hesitate to type a question in there and let us know how we can help you. We're here to make sure that you're ready for your certification. So we've gone over an immense amount of information. Chapter 1 is one of the longest ones, so you've made it through that. But it's talking about all the things that we're going to cover for our 901 section. We have different hardware, different things that we plug in, different ways that things work, whether it's wired or wireless. We have full computers, meaning towers and systems, laptops, cell phones. We have all kinds of stuff going on. So we went through a lot, but most of it should be familiar to you. And we have 2 more chapters that we're going to knock out in this section, and then we're going to take a mental breather and then come back for a little bit more. So make sure that you guys are following along at a good pace, that if you have questions, you submit them, because that's the only way you're going to learn is by asking questions. And that if there are any issues that you have tech-wise, the video's not working for you or the audio's not working for you, please let us know so that we can get you back on track. All right, give me a moment. I'm going to share my screen again, and then we'll jump into chapter 3. All right, so we are going to be talking about different motherboard components and the CPU. We're also going to talk about the power supply, and that is a very important part. And when any of these things break, how in the world do you go about fixing them? So you'll keep seeing this picture of a motherboard, but I don't want you to feel like all motherboards are exactly the same. We have different sizes and different components on different motherboards, and you should be familiar with some of the most common. The first one we'll look at is an ATX. Now the size of this thing is what makes it a little bit different. It's the bigger version of the micro and mini ATXs that we'll look at here in a second. This is older, but they just keep revising it, and that's because it works. The CPU itself is really close to the cooling fans on the power supply, which make it really efficient. And we'll take a look at how we get that airflow on our motherboard and our cooling specifically for our CPU a little bit later this chapter, actually. Now, one thing I want you to keep in mind, and this is for all motherboards, not just the ATX, that they are different sizes and have different slots and capacities, meaning how many things they can have plugged into them. Now, with that being said, you need to make sure that whenever you're either building your own computer or purchasing a new motherboard because something has happened to yours, that it is compatible with what your goals are. And one of those things that I think a lot of us forget that aren't kind of doing this every day is that this thing has to fit into the case, meaning the housing or holder, the outsides of your computer. And not only does it need to fit, but you need to make sure that it's compatible with your case so that when you go to attach it, meaning put the screws into it to hold it where it's supposed to go, that everything's lined up and you're not drilling new holes in anything. So we have the ATX, we also have the mini ATX that you're looking at now. Most of the same features, but it's a little bit smaller. So all the same plugs and components and opportunities here, compatibilities as well. But the size of it is 11 by 8 versus the larger one here that you'll see is 12 by 10 per se. So the smaller version is the mini ATX. but it gets smaller than that, and we have a thing called the micro ATX, which is again a little bit smaller. Now, it is backwards compatible, which is good, but it has fewer ports, so you do lose some of the convenience of having all the input and output ports that you do with a bigger version of the motherboard. And this one maxes out at 9.6 by 9.6 inches, so it is a perfect square in comparison to the other ones that were rectangular. Now we have a mini ITX board that is even smaller, and this is 6 by 7 by 6 by 6, so almost perfect square, but not quite. Again, much, much smaller, used usually in an industrial application, meaning that it's going to be in a warehouse or factory of some sort, and it also consumes a lot less power, which is great when you're implementing a lot of them in the hundreds. We can also use them in smaller places in our homes, like HTPCs, which is home theater PCs. If our older firewalls will have this type of motherboard in them as well. And what we call, or what I like to say CompTIA calls, carputers, which are actually car computers, which means most of our newer cars, let's say, gosh, even the last decade, have computers inside of them. Now, it may not look like it to you, but there's a lot going on as far as data being processed all the time in the background. And so your computer, excuse me, your car has a computer on board. You just don't necessarily see it or interact with it like the laptop you do at home. So there are different types of motherboards, and you'll notice that this one is very small, and it's 6 by 7 by 6 by 6. And we, of course, have larger ones or examples that are going to be the 10 by 12. So the example here I want you to take a look at are just the different slots and different amount of things, to be honest, that you can plug in. Different cards, different input and output ports, and where they're located. So let's take a look at some of those slots and where you plug everything in. So PCI cards and PCIe cards are going to be your primary places to plug in those internal cards. So we saw an example of those expansion cards earlier, and we saw a list of those. This is where we're plugging them in on our motherboard. And this is to make sure that all the data from those cards can make it through the circuitry, and the data can be processed by our CPU, get a response back, and do whatever it's supposed to do, depending on what kind of card it is. Now, your RAM is your memory. This is all that short-term volatile memory that we have, random access memory. And again, like I said earlier, it has to be installed in pairs. So you'll see two different opportunities for pairs there. And this is where we're going to install our actual slots. One thing I want you to make notice here is that you'll have little white connectors on the end. And this is where you make sure that the RAM has snapped into place, per se. So you push on it, you have it snap into place, and that's how you know that it's seated correctly. So when it's seated correctly, it is connected. But if it hasn't popped into place, that means it may not be connected well and not communicate with your computer. So chipsets are going to be all around your board, and most of your components are going to have some type of chipset that it communicates through. In regards to the picture that you're seeing here, you have your CPU connected to a chipset, meaning that that's where it's going to process some of its information or memory, or data processing to push it out back to the component that provided the information in the first place. So it's a gateway, per se. In the second picture, you'll see a heat sink that's connected to the CPU, and you'll have different chipsets underneath those. And these are really just going to be scattered along your motherboard, holding information for each of the different components. The first one we looked at today was actually the chip where all of the BIOS information was being stored. Now, your CPU socket is super important, and that's because you need to make sure it's the right type of socket and right type of CPU that go together. Again, compatibility is something you'll talk about and hear about a lot in IT. So there are different types of CPUs. There are PGAs, LGAs, and ZIFs, Z-I-F. And that stands for Pin Grid Array, Land Grid Array, and Zero Insertion Force. So the goal here, compatibility-wise, is if you have pins on your actual CPU chip, you need to make sure that there are holes in the CPU socket to plug it in. However, if there are pins on your CPU chip and pins on your CPU socket, they're not going together, right? Those are not compatible. So making sure that anytime you have a hardware upgrade or exchange or replacement, you need to ensure that those things are compatible with each other so that you're not going to come across any issues. So remember we talked about the bus, meaning the lanes per se that data are transferred from point A to point B in your system. So this is the speed at which how fast that data can move between the component and the CPU and then get a response from the CPU. So there are different components which support different speeds. And what I will say is a general rule that you can familiarize yourself with and remember is that whatever has the slowest speed is going to be the thing that restricts all of the communication. Meaning that if you have a freeway that allows 75 miles an hour, but you put a whole bunch of cars that can only go up to 50 miles an hour, then nothing's moving faster than 50 miles an hour, even if it's allowed to move faster. However, it can go the other way. If you have a freeway that can only handle things going 50 miles an hour, well, going 75 miles an hour, you shouldn't go any faster than what the freeway allows. So whatever the slowest speed there is going to be your most restrictive. And that's going to be the highest speed any of the data can move from the components to the system itself. So Cmos battery is something that you'll see. It kind of looks like a watch battery, and it's on every motherboard. And it is one of the most important components because it is what allows all of your BIOS settings to be held in place even after you turn your computer off. So if you turn your computer off, you unplug it and you don't plug it in for a week, and then you plug it in and you turn it on and everything works normal. That's because the Cmos battery does its job. So you don't need to know this for your test or for life, but for fun, Cmos does stand for something, and that is complementary metal oxide semiconductor. Again, it's complementary metal oxide semiconductor, and that's the material that the actual battery is made of. But what it does is it ensures that power is flowing 24 hours a day to your BIOS chip and BIOS system so that none of your important system settings are forgotten when you power your system down. So speaking of power, we need to get everything plugged in. And different components of your motherboard are going to need their own power, and some of them are going to rely on the power from the main power connector. So at the very bottom, you'll see that you have a primary or main power connector. This can be either 20 or 24 pins and will most of the time be square. Now your CPU fan is going to have its own power connector, and those are very tiny pins. You see a 4-pin fan connector labeled there on the left. You're also going to have CPU power, which is going to have its own 4 or 8 power connector, and these are what those connections look like. So you have your 3-pin Molex, which you see 3 very tiny pins on the male side, and then 3 smaller holes that the connector will attach to that is a female connector. In the center, you have a 4-pin Molex, so very similar, except those pins are actually housed or protected, so they're not just little individual pins that are sticking out. What's nice about that is it's safer, so they're less likely to get damaged and will last much longer. And then you have the 4-pin Molex connector. Again, it's just a different housing or version of the one that you see in the center. So just a little bit different in regards to how those power cables behind it are housed. They're not necessarily, what's the exact word I'm looking for? They're not shielded per se in the example that you have in front of you. So anytime we have a motherboard, we have connectors, and some of those connectors we don't ever need to touch unless we take our computer apart. However, some of them we need access to all the time. How annoying would it be is if every time you needed to plug in your USB, you had to literally take apart your whole computer just to plug something in? That would not necessarily work out. So some of our connectors are on the very front or back of our motherboard so that we can have an external access to them once we put our case on. And that just means we have input and output connectors that are on the very edges of our motherboard so that when we put our case on our computer, we can plug things into our motherboard without having to take anything apart. On your laptop, you have USB connectors, you may have an HDMI or VGA connector, you'll have maybe a SATA connector, or eSATA, I should say. Same thing on your tower or system computer. You'll also have some LED buttons, or LED indicators, I should say, to show you when your computer is on or off. And those are all things that are located on the edges of your motherboard so that you can see them or interact with them without any hassle. So I talked a little bit about CPUs and the LGA, PGA, and ZIF, right? Land grid array, which you see right there on your screen by Intel. We have PGA, which are pin grid arrays, and ZIFs, which are the zero insertion 4s. So what I want you to look at here are some of the different socket types that are made by Intel. That is the manufacturer for the LGA 775, 1155, 1156, and the 3 that you see at the bottom. Now, the reason I mentioned the top 3 is those are the ones that I see most often being asked about in your practice exams and what you need to prepare for. Now, there's another major manufacturer to be aware of, and that is AMD. And they make the ones that you see on screen, among other models. But your AM3 and your FM1 and 2, as well as the Plus versions, are the ones that you need to familiarize yourself with for the questions that you may have in front of you. So there is an exception here, and I want to tell you about it, and you can take note of it, is the AMD 940, the 940 socket type. Now that might be a little confusing because for me it was the easiest to remember that Intel had the numbers, right? The 775, 1155, 1156, and AMD had the letters, the AM or the FM series. However, there is an AMD 940 that I just want to throw a quick note out that you should be aware of. So our different characteristics for CPUs are important. And I'm not going to read this to you in completion, but I want to highlight some of the things that are not our average understanding of necessarily what a CPU does or what it's capable of. So the clock speed itself is going to be how many things it can process in 1 second. So if you have, just as an example, a clock speed of 32, it's only going to do 32 processes in a second. If you have a clock speed of 64, that means it's capable of doing twice as much per second. Now, there's a recommended speed that your CPU should be running at, meaning there's a maximum to it. But if you push it beyond its manufacturer recommendations, that means that you're actually overclocking your system. You'll see this happen in a lot of gaming systems as well as higher end 3D like CAD and CAM systems. Now, throttling is the exact opposite. This is where we actually slow it down. And in a one-to-one environment like your home or your small office, there's not a huge need for this. But when you're running a data warehouse or a server farm and you have 100,000 CPUs running, if you have some downtime or where you're not having to process as many things at a time, throttling can save you thousands of dollars, maybe even more than that, in the course of a month or year. So overclocking is making it go above its recommended speeds, and throttling is forcing it to be below its recommended speeds. Now, hyper-threading is a really cool thing, and when we start talking about virtualization, this is important. We are able to make a CPU, one physical CPU, look like 2 CPUs to our computer. We can trick it into thinking that it actually has 2 different processing units in our system without necessarily having to have 2 physical ones. What that does, it allows for us to process things a little bit faster. So you'll see on screen, it's about a 30% performance upgrade. It doesn't necessarily have to be that much of a performance upgrade. And to be honest, in our current times, our current abilities to hyperthread, we can push beyond that 30% improvement. So if you have an integrated GPU, so let's stop right there and talk about what the heck is a GPU. This is a graphics processing unit. So this is literally our graphics card. So for any of us that have higher end graphics, or we're working with audio video editing, if we have a gaming computer, if we're rendering 3D on our computer, we probably have an upgraded graphics card. However, if you're a normal end user, you're surfing the internet, watching a few videos here and there, you're on social media and email and things like that, you will probably get away with and are currently using an integrated GPU, meaning that it is 100% hard set to your computer, not removable or upgradable. It is what it is. You're not upgrading it. So that's what integrated means versus one that can be detached and upgraded. Let's go down to cores, because this is definitely an important thing. So your CPU itself has more than one core. It can be a single core CPU, but we have long since gone to dual and quad core CPUs. You even heard in your phone of octa-core CPUs. So what this means is that it's still one CPU, one physical one, but it's able to move faster per se, meaning that it can process 8 things at a time, 16 things at a time. It's only one CPU, but for each core, it can process more and more information. Now, this is different from hyperthreading in regards to making your system feel like it has more than one physical CPU. This is a single CPU addressing more than one instruction at a time. This is literally giving it another pair of hands or another pair of ears so that it can process more information. So everything creates heat. We definitely need to talk about how to get that heat out. So we talked about passive versus active cooling systems. I want you to take a moment and just look at the different types of cooling systems here and see how many are you familiar with. So we took a look at fans earlier, and that is definitely active. Vents are literally just the vents in your computer casing. So wherever that air is able to make it out and cooler air can come into your system, those are the vents. On your laptop, they're probably on the sides. Wherever that fan air can come out of, that's going to be your vent. Heat sinks are a passive cooling system, meaning that there are no moving parts. And the goal of it is to distribute and get that heat and draw it away from a physical component on your motherboard. So whenever you have a CPU, when you take a look at it before you actually get down to the chip itself, you're going to have what's called thermal paste right on top of it, which is kind of the consistency or a little bit thicker of toothpaste. And then on top of that thermal paste, you're going to have a heat sink. And normally on top of that heat sink, you'll have a fan. So you'll see multiple cooling methods used in one place. Now, thermal paste is a thick paste that goes between a heat sink and a component. And the reason that we use this is because we want to ensure that we have 100% contact between our heatsink and our component. Air is not really a great conductor of heat, meaning that if we just blow on something, cool air, not a lot of heat's going to go away from it. But if you touch it, it's able to release heat much faster. So we want to ensure that there's no air between the heatsink and the component, and that it's passing along all of that heat and getting it away from that component as fast as possible. Now, liquid-based cooling systems are the most efficient and the quietest. Now, I mentioned quietest because I know that you'll come across questions in regards to which one creates the most noise and which one creates the least noise. So just kind of throwing that out there to make sure you're aware of it. But it is the most efficient because there's always circulating liquid passing your CPU or whatever your component is, literally like an air conditioner, but that never turns off. So that means all of that heat can be dissipated as it's being created, and it's being absorbed the moment that the liquid passes by. So whenever you're asked which is the most common, it's going to be a fan or a combination of a heatsink and fan. But whenever you're asked which is the most efficient, liquid-based is always going to be the answer for that. Now, when we talk about power supplies, and this is one of the most important things that you'll have plugged into your computer, and I will say one of the things that you will probably never repair. If there's ever an issue with the power supply, you will replace it. So we have different sizes, and this is going to depend on the motherboard. You have different types of connectors that we took a look at, and I'll actually put a few on screen for you here in a second so you can see the difference between Molex, SATA, and your 4 and 8 pin connectors. You have different voltage meters. Now in the US, we have 110. In Europe, they use 220. The main thing that we're concerned with here is that the right amount of power is going into our system. If you put too much power, you will fry it. The other thing we're taking a look at is how many watts of energy, how many watts of power are going to go through our power supply unit. And these are all considerations that are going to be different based on what you're plugging it into. And your motherboard is going to be the primary consideration. It's going to be the deciding factor. And then how many components you have plugged in will tell you how much power you need to draw. So make sure you're aware of those things before you plug something in and fry it, or you plug something in and it's underpowered. That can actually kill something just as fast. So here are the different types of power connectors. You see SATA and Molex there. The SATA I want you to pay close attention to because it's actually pretty easy to identify. Let me click my mouse over there. So you're going to have an L. This part is real long with the pins in it, and you have this little dip or notch at the bottom. And to me, it always reminds me of a Tetris piece per se. And anytime I see that, whether it's on the male side or the female side, it's easy to identify that straight L, and that's how I know something has a SATA connector to it. Now those smaller pins are always going to be a Molex connector, whether it's a 3 or 4 pin connector. And then on the bottom, what I want you to take a look at is that main power connector. They will either be 20 or 24 pins, and that's always going to be the primary power connection for your motherboard. So your CPU is going to have its own power, your CPU fan will have its own power, and then of course the full motherboard will have a main power connector to get all the power into it. And all of the power, the watts, the amps, the voltage, that's all coming through your power supply unit or your PSU. Now, some considerations to make sure that you have a good PSU and that it's in working order is to check for any certifications and compatibility that you need to. And if at any time something goes wrong, whether it fails or it catches on fire, or even something small happens and you're not sure how to repair it, your best bet with a power supply unit is to replace instead of repair. Everything else we'll talk about troubleshooting, but this is one of those components that you just really don't want to mess with because you're not necessarily an electrician or a power supply manufacturer. You can definitely send it back to them and have the manufacturer take a look at it, but as field reps or service technicians ourselves, this is not something that we want to open up and get into. However, we need to know when it's broken, and if it's not broken, what kind of power is it pushing? We have different tools that we use to ensure that we can test these things and diagnose. And one of the first things we'll use is a power supply tester. And you can literally just plug that thing in and see how much power it's pushing out. A multimeter is a fancier version of this. It's going to give us all the feedbacks as far as watts and ohms and amps, and let us know how much power is flowing through our system. Now, a Loopback Plug is a cool little tool. It's the third one you see there, and it's an RJ45 connector that loops literally into itself. And this is something that we use to ensure that our card, our networking card, or NIC, is online, working properly, and able to transmit and send information. If it's not, meaning you have some network issues, this is the physical tool that you would use to diagnose the issue. Now the last one we have here is called a post card. Now remember what post stands for: power on self-test. And this thing is much like if anything went wrong with your car and you had the check engine light come on, you can go to an auto shop of some sort, and they'll actually plug your car into a little machine, and it gives them a code. And that code is going to tell you what's going wrong with your car. Different makes and manufacturers have different codes, but you can always plug it into this machine and figure out what the code is. This is that same exact thing for your computer. If for some reason you can't get that error or post issue to appear on your screen, so that means it's not going to actually tell you what it is, especially if you're having a graphics issue, then it won't appear on your screen at all. You still need to figure out what the heck is going wrong with your post, your power on self-test, what's failing, what's corrupted. And you can take this card, plug it directly into your motherboard, and it will give you the code that you can use to then go look for what the problem is. Now, of course, you'll probably want to look for that code on a different device, because whatever the broken device is going to give you the error code, but you won't be able to get to the internet to research it. So make sure you always have a secondary device available when you're troubleshooting. So lots of things can go wrong with the CPU, but the most common is overheating. If you do not have a proper cooling method, then you can cause an immense amount of damage to your CPU, and then you won't be processing anything else anymore in that system. But other things can go wrong, and one of the things that I definitely have mentioned, and we'll keep talking about it, is that compatibility. You need to make sure if you are replacing or upgrading your CPU that it is compatible with the socket on your motherboard, meaning it's the right size, one of the models that's compatible, and the right type, that PGA, LGA, or ZIF. And the last thing that it says here is power consumption. We already talked about that in regards to sending too much power or not enough power to the system itself. So it's really important. You don't want to fry your components, but you also don't want to underpower your components, because they'll try and work and they'll overwork themselves and they won't be able to actually do their job. So there's lots of different cooling systems, but you always want to make sure they're working, whether it's active or passive. And if you are the average end user, then you have probably not taken care of your computer like you should. Those fans have dust on them. You've got to clean them off. You need to make sure that that air is able to make it in and out of your system at all times. So if you have fans on your computer, if you have never taken compressed air to your computer, I encourage you to take it outside on a dry, sunny day. Let me say it again, on a dry, sunny day, so no rain involved, and take that compressed air and let your computer be clean again. Let it breathe again. Clean the thing. It needs that air to make sure that it can function properly. So some motherboard issues that we'll see is anytime our computer will not boot up at all, or it's failing at random intervals, meaning it'll boot up and it'll make it just far enough, but then it completely fails. It can be one of many issues, but one of the things you should look at is your motherboard. Is there enough power going to it? Are the capacitors, which are those little silver things that are all over the place, the circles that you see, those hold and transfer energy and power throughout your entire system. So making sure that your capacitors are still there, making sure they're not broken, or that they haven't blown per se. And you will be able to recognize a blown capacitor. It looks like it put one of those round floaties on around its body. So just imagine a kid with one of those full tube floaties around it before you put them in the pool. Your capacitor will be in its own little floaty if it is overheated and per se burst. But these are just random things that you can look for. You need to make sure your Cmos battery is to full power and still in place. You need to make sure your RAM is seated properly. Again, make sure it's clicked all the way in its little place. Make sure all the power connectors are not loose and that they're plugged in all the way, because your motherboard is the central system point. So things can go wrong here, but as long as you're protecting it physically and making sure the right things are plugged in, then these things are going to last you an incredibly long time. So anytime something goes wrong, we need to figure out, can we repair it or should we just be replacing this? And most of the components that are plugged into your motherboard, you can unplug them, repair them, plug them back in. But if your entire motherboard fails, there's not fixing that. There's no fixing it. You're going to have to throw it away, get a new motherboard, and plug all that good stuff back in. So again, if one card or a single piece of RAM fails or is corrupted, you can always unplug that thing and buy a new single component and plug it in. That's considered a repair. It's a replacement of that component, but it's a repair to your full system. But if your motherboard itself has failed or has physical damage, you're going to have to go ahead and replace that. So what in the world could cause power source issues that aren't necessarily our power supply unit? Well, external factors are a big thing to make sure you're aware of. You'll see some new acronyms on your slide here, and I want to give you a moment just to take a look at it because there's a lot of text, and then we'll talk about each section. All right, EMI, Electromagnetic Interference. RFI is radio frequency interference. So these are two things that will cause, AKA noise. We call it noise. And that is, it's going to cause some type of degradation or decrease in our signal, or it could actually cause a complete failure of our signal. And when I say signal, I'm talking about anything from data transmission to power itself. You can have a power source issue or power source failure caused by both of those, as well as lightning. And that's because you have too much going on and it's going to overload your power supply unit. It'll affect it. So lightning, power surges, blackouts, we're familiar with those things. We've heard of them. We may have experienced all of those. But usually brownouts and sags are new for some people. And that's a decrease in power, but not a complete loss of power. So at any point, if you've ever seen the lights flicker, or for some reason the lights have dimmed for a little bit and then come back up to full brightness and nobody really understood why, you didn't lose power in the whole place, but you had a decrease in power. And we call that a sag or a brownout. And those can cause damage to your computer as well, which is why we use surge protectors or what we call a UPS, which is an uninterruptible power supply. So UPS, that's another important acronym, uninterruptible power supply. It's the equivalent of a backup generator for your computer, so that even if the power goes out, your computer and your systems will still have the critical power it needs for either a safe shutdown, or you can actually continue to operate for however many hours your UPS will support. Full power failure, of course, can cause issues for our power supply units, and it can actually fry them. If there's a surge in power prior to that, lightning strikes a lot of times will cause those issues. If you have power line issues around your physical city, that can cause an issue for getting power into your system. But what we want to take a look at is, when do we know that there's a power supply problem and how do we go about fixing it? So if for any reason there's no power to your system, that might be a power supply problem. It might be a problem at your outlet. So you need to take a look at, is it only the computer that has no power, or do other things around you not have power as well? If for any reason the fan stops working, I would turn your computer off immediately, because that means everything is going to overheat very, very soon. If you smell a burning, whether it's plastic or metal or smoke of some sort, you definitely want to unplug things and either go get the right person, or if you happen to be the right person, unplug it and do what you feel is best. Now, I cannot tell you the right reaction 100% here. One, I don't want to be held legally responsible for you doing something weird or wrong and hurting yourself. But two, your reaction really depends on what's happening. Do you need to call the fire department if you smell something weird? Not necessarily. But if you have a bunch of smoke coming out of your computer and it's sparking, then that might be a really good step for you to complete. So it's up to you and it's up to the situation, but make sure that you do what is appropriate for the situation and make sure that you keep yourself and the space around you safe. The last thing here is if you hear a really loud noise, that means the fans are maybe off center or they're hitting something. Something has either fallen or come loose. You definitely want to start unplugging things at that point and power down your system. So what are the considerations when you go to fix this or when you're troubleshooting or diagnosing it? You need to see overall how much power is required to make sure your system can run efficiently. Can that much power come from your power supply unit? If you have all of these great peripherals and components plugged in, but you don't give them enough power, you can cause damage to everything. You also want to make sure that you're not putting too much power into your system. Of course, we've talked about frying that. When you make the decision or are facing having to make a power supply unit replacement, you need to make sure that you have not only the right size power supply, but that the connectors are the same as your old one and that it's compatible with your motherboard. And the very last one is making sure that the right amount of power is going to come out of this thing that is, again, compatible with your system. So if you are in Europe and you buy a 110 power supply, that is not going to work because they're in a 220 environment. Same thing with the US, making sure that it's compatible for the environment you're in and the system that you're going to plug it into. So for this first section of A+, you have officially made it through 3 sections. So that is a good amount of information for us to start with. And I want to say congratulations on taking your first steps. And it's been a while since I've seen you, so here's wanted to say hi again. I want you guys to take a quick break and let your brain cool off. I'm going to look at some of the questions that you've asked on our Google Classroom. I'm going to be answering those questions. I want you to take a look at your books if you already have them in front of you. If you're one of those who are still waiting for it to be delivered, I want you guys to remember that you have about a 3-chapter per day during the weekday pacing on your reading. So if your goal is to complete this course in 2 weeks, then you should be reading 3 chapters per day, and that's only for the weekdays, Monday through Friday. So usually what happens is that people read about 1 chapter a day, and then they'll knock out a good amount on the weekend and get caught up and able to come back and look at these videos for parts that you need a refresher on, which is why we record it. So take a moment, jump into your book for a little bit and take a look at the information that matches with what we've gone over. Ask questions on your Google Classroom wall. That is really, really important. And you will have a new link to join Day 1, Section 2 here in a little bit. And so what I want you to do at this point is soak it all in, breathe, ask questions, and we'll see you back in a little bit for Section 2 of the first day. Congratulations again on taking A+.